Hello students, welcome to your science class. We have successfully completed learning chapter 13 Fun with Magnets of your NCERT science textbook. Today we will revise the entire chapter and will have a look on the main key concepts of magnets we have learnt. Beginning with the definition of magnet. Magnet is a piece of iron, steel, etc. which has the property to attract and pick up other metal objects. This is the definition of a magnet. Let us see an introduction to this chapter. We know a crane in a junkyard usually separates metal objects exclusively from the scrap with the help of a huge magnet. Many other such examples where we see and use magnets are, we have many stickers attached to a fridge door or almirah with the help of a magnet. Several other purposes served by a magnet are a pin holder holds paper clips or pins attracted towards a magnet. Your pencil box lid sometimes have a magnet tightly holding the lid without a lock to it. The music system speakers have magnets inside them. The magnets play a key role in their design. The fridge door are held tightly to not loosen the door and avoid the cooling to escape with the help of a magnet all over its lining. And there are many more examples like this. The fridge door usually is held tightly, and to avoid the cooling to escape, it has a magnetic lining all over so that it helps and avoids the cooling to escape. And many more such examples are there where we use magnets in our daily life. Next is how magnets are discovered or how magnets were discovered. We came to know an interesting story of a shepherd named Magnus, whose experience was the story behind the discovery of magnets. The small iron stick he used to carry with him, which got stuck to a rock on the mountain side, made him think about these magnets and its properties. Initially, those rocks which attract iron are named as magnetite after the shepherd's name, whose name was Magnus. Over several years, this discovery led to several studies knowing that the substances which have the property of attracting iron are known as magnets. Those rocks which have the naturally occurring property of attracting pieces of iron are known as naturally occurring magnets. And those materials which are made by man from the pieces of iron are known as artificial magnets. The different shape of artificial magnets used are bar magnet, horseshoe magnet, cylindrical magnet, ball-ended magnet, ring magnet, disc magnet, magnetic needle, etc. are designed to serve the purpose of need. So these are the different shapes of magnets that are man-made or artificial, available for several other uses. Then we learnt about magnetic and non-magnetic materials. We have observed an activity of testing numerous objects around us which were attracted by magnet and also not attracted by a magnet. Out of all the objects, we observed materials made of iron, metals like steel and brass are attracted by magnets. So then we know that the materials that get attracted towards a magnet are magnetic materials, for example, iron, nickel or cobalt. And those materials which were not attracted towards magnet are non-magnetic materials. We then tried to find out whether soil is a magnetic material or a non-magnetic material. Then, on performing an activity, we observed that soil alone is not a magnetic material, but it has a mixture of magnetic and non-magnetic materials. As when a magnet is rolled on soil, few materials got separated from soil and got stuck to magnet, and as these are the magnetic materials. Then coming to the poles of a magnet, where we try to understand an activity by keeping a bar magnet on a surface spread with iron filings. We observed most of the iron filings got attracted to the ends of the bar magnet. Hence, we come to know that the poles of a magnet are near to the ends. Then we come to know that Earth itself is a huge magnet balancing the directions of Earth, which has two poles, that is North Pole and South Pole. We learned how to find directions with the help of magnets. In finding directions, we learned a story of a Chinese emperor who had a chariot with a statue of a lady with an extended arm that rotates in any direction. And the statue always pointed towards south after coming to rest position, helping the traveler to understand in which direction he is traveling. After understanding an activity, we came to know that a freely suspended bar magnet always comes to rest in the north-south direction. Not only the magnets, but also the sun helps us in finding the direction. As you know, the sun rises in the east. If you stand facing east direction, towards your left hand side will be the north direction, and on your right hand side will be the south direction. And on a magnet which always seeks to face the north direction, it is called the north pole of a magnet. And a magnet which always seeks to face the south direction, it is called the south pole of the magnet. For many years, travelers used magnets for finding directions by suspending the natural magnets with a thread. To make finding directions easier, man discovered a device called compass, based on the property of magnets. A compass is a small round box that is covered with glass on one side and has a magnetized, freely rotating needle fixed at the center. It has a dial with directions marked on it, and the directions are known when it is held or placed without any disturbance at one place. Whichever direction you may face, the needle of a compass also comes to rest in north-south direction, as it is a magnetized needle, and the direction you would like to travel can be understood by reading the dial of the compass. We learned how to make our own magnet in a simpler way. In the process of making a magnet, we take a piece of iron, place it on a table. We'll take a bar magnet and place it at one of the poles near one edge of a bar magnet, and without lifting this magnet, we move it along the length of the iron bar till we reach the other end. We will repeat the same for several times until the iron piece gets magnetized. We have to remember that during this process, the pole of the magnet and the direction of movement of the bar magnet should not change, and this can be applied to any iron object to magnetize it. We also learned how to make a compass by our own. We used a magnetized iron needle, inserted it in a cork or a thermocol, and we will let it float in a bowl or tub. And we should place the cork with needle in such a way that the needle should not touch the water in the bowl. We learnt about attraction and repulsion between magnets. We performed an activity of suspending bar magnets and their ends facing each other in different positions, and we have seen the observations. We observed that opposite poles or unlike poles of magnets attract each other and same poles or like poles of magnets repel each other. We also come to know that the magnetic needle of a compass usually gets influenced by an external magnetic effect. Few cautions to be taken while handling magnets are: the magnets should not be heated, they should not be hammered, and they should not be thrown from heights. In such cases, they lose their magnetic properties if they are heated or hammered or dropped from some height. Bar magnets should be kept safe in the following manner, where placing the two magnets with unlike poles on the same side, separated by a wooden block, and the ends should be covered with soft iron pieces. And for a horseshoe magnet, the ends should be covered by a piece of iron as shown in the image. As magnets influence the activity of most of the electronic devices, magnets should be kept away from these electronic devices. So this is about your chapter Fun with Magnets. Thank you, children.